So hello, we are continuing on our Advent of Code 2020 practice journey to get ready for Advent of Code 2024, which starts in, what, 3 weeks? Today's the 9th. Anyway, so here's our day 6. As your flight approaches, the regional airport has a customs declaration forms that's given to the passengers. But you have no problem answering yes. But the person sitting next to you has a language barrier and asks if you can help. So there's groups of people. They're separated by a blank line, and each group of lines that are not separated by blank represents a single person in that group. And the letters are the questions to which they were able to answer yes. So this guy answered ABCX, ABC. This guy answered ABCY, and this guy answered ABCZ. And so the idea is that you're supposed to add up how many different questions were answered yes by members of the group. So here's a member of a group that only has one person. ABC are the questions that are answered, so there's exactly 3. Here is a 3-person group. Each person answered a different question, yes, but they're also ABC, so the answer here is also 3. This group has 2 people, AB and AC, but that's also 3 different questions answered yes to. The 4th group has 4 people, and they answer yes to only question 1, so that's a 1. And the last group has 1 person who answers a yes, but only to question B. So they want you to add up the number of yes answers, basically, for each group. So 3 plus 3 plus 3 plus 4 plus 1 equals 11. So that's what we need to do. Of course, we need to do it on our bigger input. So here's our test input. Well, first let's start up an Emacs. Should I use the newer or the older Emacs? Let's try the newer one again in case we notice any other things that are weird. So I'm going to create a buffer. One of the things that I use a lot is I use numeric counts in front of commands. So that was a 5 meta B, which means go back 5 words. The dots and underscores separate words, so that's bin 2, 1, 29, and Emacs. That gets me to desktop, and I only know it's 5 because I've done this a lot, so that I can kill that and type NA tab to get into the folder I want. So that's where I'm creating the file. So we're on 06. I know that sometimes I've called them day and sometimes called them just the plain number. I don't think it much matters. 6T. So here's our template. And I don't remember if I copied this, but if I didn't, I will copy it now. This is our sample, which goes here. And then we need our real input. Which goes up here. And then I can medx eval buffer to evaluate the whole buffer. Both of those are not defined. I'll write it out so we don't have to do this again. So I have to add up the number of yes answers. So I have to break up. So that was 3. This is, yeah, 3, 3, 3, 1, 1, and I give this 11. So again, we're going to loop with groups equals split string input string with 2 new lines. So a blank line in between. So for group in groups, so we don't care how many lines there are. We're just adding up the different and yes answers that are in there. So for uh, answers equals loop for line in split string group with one line with answer cross. So this is going to be the individual lines worth of answers to push new char onto answer. Push new is a macro. It will put the char there unless it's not there. It's using lists, and so therefore it's inefficient if you're got anything more than a few. But these problems usually just have a smallish number. You could also use a hash table. It seems a little bit more trouble than it's worth. And so the inner loop is going to add things to answer. And finally, from the outer loop, we're going to return answer. So we have to just sum length of answers, I think. And that's it. Oops. So another loop macro expansion problem for line in split string of group to across is misspelled. Yep, okay, that's better. So let's see if we get 11. So Control X E is to run a keyboard macro, and Control X Control E is to evaluate an expression. Sometimes my pinky isn't on the control, or sometimes it's the keyboard that's being a little flaky. I don't know, but in any case, easy enough to retry. So length answers, not answer. And 11 is indeed what we get. Let's put it in there. And let's see what we get on our real input. 6585. Oh, we get rid of this. And that is in fact the correct answer. So, part 2. As you finish the last group's custom dictionary, you notice that you misread one word in the instructions. You don't need to identify the questions to which anyone answered yes. You need to identify the questions to which everyone answered yes. So you have to, this time you'll have to remember how many people are in a group and count up the number of times you see each answer and only add up the ones where the number of answers is the same as the number of people in the group. Okay, that's not too hard. So again, we're just going to copy this and then redefine it for part 2. Optional part 2. And this guy is going to be 1 with input string and t for the part 2. He's defined. We need say so. In fact, a hash table is not an unreasonable thing to do. So the other thing is not associating lists, but okay. So with answer hash make equals make hash table. Right. So inside of here, no, initially inside of here, no, inside of here initially, that's how you spell it, yep. Answer hash, because we don't want each group's answers to be polluted by the previous graph, and we probably want to swap these two lines. Initially, clear hash, answer hash. Answer and number of members equals 0. So every time we get a line, we're going to do two things. We're going to incf number of members so that we know how many members we've seen in this particular group. And then we're going to prior entry equals get hash char of answer hash. So that's to see if we have any if prior entry to incf get hash char answer hash, else do setf get hash char answer hash 1. I think that's so incf, setf, and friends are also Lisp macros, and they're very useful because here where I say setf of the get hash, I'm just providing the function that gets an entry from the hash table, but the Lisp system under the covers knows how to transform that into a get the current answer and then update it using, in most cases, it's called sethash, but whatever it's called in that particular Lisp system, that's what it knows how to use that. And the macro expansion of setf is built in to know about all of the places and getters that come with Lisp, but you can also extend it. So if you make your own structures, you can say def setf, and you can say here's how to transform a read reference into a write reference for this particular data structure that you created yourself. So the idea is that if we didn't have a prior entry, we're going to create an entry and we're going to have its value be 1. If we did have a prior entry, we're going to increment it So at the very end down here, what we have to do is we have to return loop for x being the hash values of answer hash. You can get either the hash keys or the hash values or both in the same pass through the hash table, but we only need the values. Count equal x number of members. So if the value, which was the incremented count of how many times the person on this line answered, how many times the persons in this group answered the question yes. If that's equal to the number of people in the group, then that means everybody answered it yes, and then that's our answer. Now we only want to do that on the part 2, so we actually want to go back to the previous thing on part 1. So oops, I didn't mean to do that. My fingers are, I'm a touch typist and I keep my fingers usually on the home row keys, but if I have to move them off and don't look, I sometimes get confused. So this is for if part 2. And for part 1, we just want is it hash count? No. So medix apropos hash table count of answer hash. So that's how many entries there are in the hash table, no matter who did it. So now we can make sure that that finishes our loop. And then we can go to the end. And so we want to again make sure that we get the same answers in the part 1 case. Nope. Length of 3. Where's answers? Right. So in the okay, so we can make this. So I was trying to collapse 2 different things. In this one, we're returning the list of all of the answers. We should do that. So what we should do is when so this time we want the hash keys. For x being the hash keys of answer hash using hash value y. So now x will be the key and y will be the value. When equal y number of hash, we want to collect x. So now we're going to return the actual A, B, C, D answers. And then here similarly, we're going to just loop over the hash. So loop for x being the hash keys of answer hash, collect x. Part 2 is this. Part 1 is this. That's the loop. That's the end of the function. So this is a list of answers. I was forgetting that. And in the part one case, it might be a little bit overkill, but to use a hash table, because then we have to loop through the hash table. But so let's try, make sure the part one case still works. We get 11, and we get 6583. So I don't know what we should get for our sample. Did it say? Yes, 6 is what they're expecting. We got 0. So that's not right. Uh, we do the hash table stuff always. So let's actually look at the hash table. So here, before we return, we're going to go into the debugger. Oh, part 2 sample. Silly me. I think that was maybe the problem. There was nothing in there, and 0 is the appropriate answer for nothing in there. Continue, 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 continue. 6. So that is in fact the right answer. So we don't need the debugging statement. It was because I was trying to use an empty string, which is the default. I should make that nil in the template. And that way it wouldn't be faked out. So let's get the real answer, or try to get the real answer. 3290. Yep. Okay. Good job. Thanks for your attention.